All right, so today we're looking at file streams and object serialization. Please let's pay attention. If you're in the other venues, please, I need your attention today because we have a bit of information to pass through and maybe just test the code if there's time. So, all right. Okay. First of all, before we start investigating this topic, we need to understand the very fundamental concepts that we use every day. So, with this specific topic, we have to consider how our file system works, how we read the data, how we write the data, whether it relates to just objects or classes or whichever category it falls under. And the first thing I usually ask, or at least I usually like to ask students, is the difference between data and information. All right? I asked that thing in software design one, if you remember. So it's important because it helps us to understand a great deal while we go along. So what is the difference between data, information, and knowledge? Those three categories. Just humor me, all right? Say something. I can start with the closest person to me, so I can try. Yeah?
So data, information, and knowledge.
Yeah.
Knowledge is your understanding, I could say. Information is what you receive. Data is what you transfer between devices.
Okay, good try. Any other person? Yes.
So data is I know that information is processed data.
Yeah.
And then data is ones and zeros.
Okay. Yes.
Data be like just like those more aspect of like it needs to be interpreted, otherwise it's kind of like just numbers or facts.
Can I build on what Andy said? Andy said information is processed data, and the knowledge is just processed information.
Okay. I think your hand was raised. You have something to say?
Yeah, I think data is like what's of information,
Mm-hmm.
and information is like something that can be sent and received,
Okay.
and knowledge is like the amount of knowledge or things that you know.
Okay. Well, there is some form of relationship with three of them. That's why I asked that question. All right. So yes, he was right when he said data was raw information, or rather, data was raw. What do you call it? Raw events or records you get from an event. So basically, those raw information, not information. Let me use the word correctly. It's just raw events or records you get from some object or from instance or for some activity. All right. So that's that raw event or raw record that is gotten is what your data is. Information is when you process that data, all right, to answer some basic questions like what, when, how, all right, things like that. Then knowledge is the insights you get by answering those questions. It gives you a bit of knowledge in terms of how to now apply that information, all right. So there is a relationship with all three. Now, data in itself can be temporary or permanent or persistent data if you look at it. And the reason why I'm saying that is because when you begin to investigate the next few slides, you would see that most of what we're talking about is data. All right. If you look at how we handle our variables, for instance, when you allocate a variable a specific representation, maybe a literal, for instance, a string literal, maybe a character A, or your name, or even a value, all right? Notice that when you reset that PC and put it back on, that variable you've allocated that specific data has lost that data. It only happens when it's within that scope, right? Yes, so these are temporary data. So they don't necessarily stay. They are meant to perform some kind of operation and give some useful insight or information from that, right? Then you have a more persistent data that you can now store in your hard drive, your hard disks. These are the ones that when you shut down the system, right, you can put it up again. And most times they're associated with several file types. So you have your .txt, right? What's that? Text files, right? You have your .csv, you have your .doc, and the rest of, or even .pdf, right? And these are meant to be able to retain the information or the data that you've processed, so that you can revisit that information time and time again, all right? So the outline today, we're going to look at basics of files and streams, how this data is sent through our various streams. And we know that we have 3 streams in Java. At least in programming, you have your what? Your input stream, your output stream, and your error stream. All right, these 3 streams inform us of the kind of operations that can take place when we use them. Right, most of the methods we use, most of the functions we use are aligned with these 3 streams. Then we look at files and directories. How do we read to a file, write to a file, or even read an object or write to one that we can use within our programs. We have binary and character input output streams that we'll look at soon. Reading, writing, and so on and so forth. All right. And we've used the scanner import tool before, and that allows us to do what? To read the information that's sent from your PC. We also have the formatter as well that we're going to look at today, and that will also do the reverse that allows us to output certain information as well in terms of your byte streams. All right, let's just jump into it. All right, I did ask about what the data is initially so that we can get us started here. And we know we have your temporary and persistent data that allow you to store the information. If it's temporary in some variable within a scope, after that scope it exists. If it's permanent, it stores in some associated file type that we can retain that information, and on some hard drive. A file in Java is viewed as a stream of bytes, all right? And usually your OS allow you to read that information and always add a marker at the end of that file. We've used that before previously, and that's an EOF. What is that? End of file marker, yes. So now here we look at what the file stream is. It is used to input output data into a program, either in terms of bytes or in terms of characters, all right? And the diagram here just shows you an array of some sort that shows you that at the end of the array you have an EFO marker that notifies the compiler or the program that you've gotten to the end of this specific file. All right, in terms of what our streams are, we have our standard input stream, output stream, and error stream that we can use or that we use within our program. And most of the methods we see, or even functions within our C programs, those of you who don't see, are associated with these 3 streams. All right. The input stream here normally imputes bytes from your keyboard. So when you put an information there, it receives it as bytes. And we know that bytes are basically 8-bit integer variables. So there's a version of integer variables, but they are 8-bit in size, meaning they are more compact and store more information. Your standard outputs what characters to screen. So most of the things you see in your console or in your display come up as a character representation, right? And the last one is your error, which streams and objects that normally outputs character-based error messages to the screen. So whenever you have an error within your syntax, you notice that you have those red lines popping up with signifying where the error is, what kind of error you have, and what line the error is. The type of error is associated with your system error, all right? The type of error, and we'll see several types of error as we go along the slides today. Right, so a class system provides methods like your set in, set out, set error to redirect standard input, output, and error streams to other devices when required. And because we've done your set and your get methods, you understand what when we see what these methods are. Whatever is coming from this class from some method that can be used in your operation. All right? You understand that? Is it clear? Some of you seem confused. In the last example last lecture we had, we did a set method and a get method. Do you remember that? No? You haven't revisited that example? No? Okay. Okay, so if you have a class, all right, and the class contains several private instance variables. Instant variables are private, so it means that the only way to access the instant variables is by creating several methods within that class. Why? Because every private instant variable cannot be accessed outside, but except with the methods defined in the class. Those methods allow you to get and to set those instance variables. All right. So when you see a set with any other word attached to it, set value, set this, and those things were specified as instant variables, it means we can manipulate those private types and set those values. If you see a get, it means we can retrieve information from those private types. All right. So what this is saying is that there are methods within our class system that allow you to set in, out, and errors, meaning that these are methods on their own that are defined within this class here. All right, and it allows you for input, output, and standard error messaging. All right. In our mainstream classes, we have the following, which is file input stream, which is a byte-based input from a file output stream, which is a byte-based output from a file reader, which is a character-based input from a file writer, which is character-based output to a file, object output stream, which is in conjunction with the file output stream. It allows for object serialization. I will talk about that when we get to that slide. And we also have the deserialization. So the first one allows you to write to, and the other one allows you to read from. So you serialize when you're trying to write to the object, and you deserialize when you're trying to read from that. But we'll get to that stage. Next, we know our scanner, which is a character-based input from our keyboard. Again, it retrieves the information that you press on your keyboard when the user tries to enter some information in your program. And you have our formatter, which is a formatted output. It's like a printf that allows you to format a text-based string to your output. All right, so it's similar to when you have your system.out.printf. All right. All right. Here we're talking about our class files. For a class file, what is being pointed to us in this slide is that we have 4 constructors, right? And the constructors allow us to take in certain arguments that we can use within our program, specifically when trying to read a file. So assuming there is some file that is saved in some location within your program, and you want to be able to access that file, all right, you will need these constructors. If you can remind me, or if you remember, when we have multiple constructors in a program, what's that called again? Constructor overload. It means that it's giving us more than one way by which we can initialize variables or access certain instant variables within our program.
Wouldn't that be if the constructors are all the same?
If the constructors are all the same, yes, but they'll have different parameters. Yeah, yes. Even we have something similar with methods as well. Remember, don't try to overload or override a method. Yeah, yeah. Okay, so in this case, let me quickly pull up an example here so that we can go along with this. So I took the privilege to create some file. Maybe at the end of each class, I'll always release some code, some examples, my own examples. That just makes things a bit easier to understand, because some of the examples there would have to actually implement them to see what the outputs are. All right. So in this case, I explain what the class file is. You can read that later, but my interest now is in the 4 constructors that have been specified in that slide. The first one here is a file with a string path name required. What that means is that it's taking in some relative path that allows the user to access or write to a file within the default path, usually where your project is created. So if you create a new project in your Java, in your NetBeans right now, you create a new project, that's going to be stored, if I'm right, in documents, a NetBeans project, or it may be anywhere you point it to, right? Now, this part, when I just say new file, creating an object, and this is the constructor I'm using here, so new file, and I have reports.pdf in double quotes. What that is that if I'm going to create that, it means in that default project, it's going to drop that file there, right? If I'm reading from, it means that in that default project, that file must already exist there, right? So that's different. Okay. The next constructor, that gives us a bit more. It means that we now have two arguments instead of just one. So instead of a path name in string, you can now take in two, which is a string parent and a string child. In the first case, we now have some path that points to where the document is, and the last case is the name of the document you're looking for. So in the first case is the path to where the document is, and the last case is the document name you're looking for. So that's another way to actually read or write to reports.pdf. In the third case here, we now have a file parent and also a string child. So in this case, we have a directory that we specify to us completely. So that directory already exists and has a name, which is called dir, that we've used in our program. But we can as well just point dir to that location, and the next argument will now be the file in that location that we're looking for. All right, so this is another way to write that. There's an example there called 3.12 that we'll look at soon that explains that. And in the final case, we can actually point to a URL link if we want to, and this will now create a new URL with some address that points to the file we're looking for. So assuming that your file is in some server somewhere and you want to retrieve it or write to it, right? So it just gives you an idea. If you're working with the server and you want to read or write from that, you can use the URL method as well, right? But the other ones is if you're working with a specific location, you don't want to write documents, but you want a specific location to put it in, you can use the directory method. And the other one here is if you have a default location, you just want to paste your file there or read your file from there. That's another way to go. So yes.
I see there's a C // Z just because Windows uses backslash.
Yes. So that's the next line I'm about to talk about.
I'm sorry.
Yeah, no, it's fine. So file and directory paths start differently on different operating systems. All right. So if you're using Windows, you will have the C// on Windows. If you're using Unix, you have the / instead of the backslash. And when you're writing the path on these things with a Windows system, you always use 2 /. You know why? Because the / in your Java program, or a backslash in the Java program, sorry, it's seen as a syntax, a program, So as a keyword. So to enable it, you have to use it twice, so that it's enabled. So again, two things we see in our example is that we've seen. Question?
So do we always use it? I say no, it's in docs, school, things, that's the fun part. So we always use twice when we know
Twice.
Okay.
Anytime you have a backslash, do it twice. Okay. So in this case, we are pointing out that we're going to see two relative parts. That's right, two parts. There's a relative part and there's an absolute part. The relative part is where we just specify the name of the file, and it figures out that, okay, this name is in some default location, all right? And the absolute part is going to now specify the URL, but specify the path, the direct path. So C dot / this, all the direction gives you an absolute path that this is where the file is, all right? So be mindful of that when using that. The example I have here is for an absolute path. So we have, say, absolute path would be like a new file, then I specify where the path is, ending with the path name. So notice now we have / users / equals / data.csv. So meaning that this is the location where the file is, right? But for an absolute for a relative path, I just specify the name of the file. and it's going to by default check my default location, which is where the project is being stored. Is it clear?
Yeah.
Okay.
So
All right. So the last, yes.
by default location, you mean where the project is stored. So if I'm searching for a file, for example, I'm searching for my pictures, and my pictures are in the default file. I don't have to put my URL.
Yes,
because
it's already there. Just put the picture name dots, whatever extension you have with that, and it's going to pick it up in that
But
space.
if I want it from another file, I have to mention it.
Yes, yes, yes. All right, so we now have the last part here, which is the separator character. So the separator character is if, or how will I put this? It allows us to work independently, this irrespective of the OS you're working from. So because we know that Unix take the forward and Windows take the back, if we use a separator, we can ignore that rule completely, right? And just whatever code you write will work on any system you're running it on. So how does it work? There's an example here. So let's look at example 3.11 and 3.12 mentioned above so that we can see what's happening. Then we'll come back and continue on this slide. So let's go down a bit. So as you can see, there's a bit of code we'll have to go through today. Just as we go through the text, I'll refer to this code just to make things easier and give example to each section so that assimilation becomes much better. This is where we now use the file separator here. All right. So we're trying to avoid the use of the backslash. So I just need to specify in partnership form what the path is without any forward or backslash. Just put the file separator there. It knows that it's going to inject whatever file separator is required for use, and that's now form my path. So I can just put my path in here in my new file, and that problem is solved. All right. So this is more straightforward. Question?
No.
Okay. Then in this case we can do that and get what the absolute path is, and in this line here we can also print and check if the file exists or not. Right. So while here we can get what the length of the file in terms of bytes is, and the reason why I'm using these specific methods is because it's associated with the slide we're currently looking at, and I'll go there in a bit. But what they do is to help you at those methods that are in the file class. So the file class is able to get absolute path, meaning that give me the path where this file is coming from. Secondly, check if the file exists to begin with, to be true or false. And thirdly, what is the size of the file in terms of bytes, right? If we run this quickly, we should be able to see, okay, let me close this first. We should be able to see that in the very first output, the absolute path is shown here, where the file is. Then does the file exist? It is true. And what's the size currently? It's this, right? So it depends on the file size or the file you're working with. Now, if for any reason I decide to tamper with the path, for instance, let me just change a character here, and I run this. It should tell me if the path is true or false. As you can see there, it's false because that path I just chose now does not exist. And that's why we have a file size that is what? 0. So you're able to check this thing to see if the file exists, what the file size is, and also manipulate these files by knowing the methods associated with your file class. All right? Okay. So let's look at the last example before we continue, which is example 3.12. In this case, we are using 2 constructor types to show how they implement. The first one here we use with our normal relative part. So we're looking for reports. So the constructor 1 file object is created using constructor 1. So here file dir is equal to new part. This here is also a method that checks if it exists. Remember this, it returns true or false. And if it's false, then it's going to create the directory. It means that the directory does not exist. Let's create a directory for the very first time. Right. If it's true, then it already exists. It's going to ignore that completely. The next is constructor 3. And with this one, we've decided to use the true part, dir, and the file we're searching for sales.pdf there. And we'll run this, we should be able to get that. So if we say print the absolute part to see if it's the same, this will also give us the absolute part. You can see that here in this line, which is the part. So the part it's pointing to here is the absolute part where that file exists. There. All right. Okay. Again, let me go back to the exercise we just did so that it's much clearer now. All right. In the first case, we talked about the various file types or the various constructor types, and we showed you for 1, 2, 3, and 4. The example I'm referring to here is example 1, where we just have a relative part, and example 3, where we have some directory that we are pointing to, right? And a file name, right? And that's what we've shown there. And in the last case here, is just trying to show you when to use a separator to avoid the platform issues of either having a backslash or a forward slash in use. Okay, let me minimize this now. All right, so in essence, what I've just done is just summarize this entire page. All right, so in case you find this difficult to understand, you have that information to go through and the examples to support you as well. And like I said, there are methods that are associated with our file class. So these are the class file methods here. So we see we have the Boolean can read, can write, exists, is file, is directory, and is absolute. We also have the string, get absolute parts, get name, get parts, get parent. We have the long length, long last method, and your string list. These are most of the common ones we've used. And I think we still have some more, if I'm not mistaken, out here. But if you look, we already used the length. We've already used the get absolute parts. We've also used the exist, and I'm not sure that one again. And we use more as we go along, right? We use more as we go along. The example they have here is doing the same thing. If you have some time, please try the example out. Again, this example is already in your textbooks, and you have a copy of that, I believe, by now. Try the examples out, all right, and see the outputs you get. The most important thing is that we are able to use these functions that have been measured or mentioned in our file class method or class file methods. All right, so the next topic of interest is our sequential access text file. And what this is how we are able to store records in order by record field key. So what you're saying in essence is that the format at which we write our information or our data, the way it's going to be represented and stored and accessed is all up to us, but we have to be aware of how the output is. You know, when you're doing your printf or your print statement, you use certain specifiers because you want to arrange it in a specific order and format, right? And that's entirely what we're trying to refer to in this case. So here it says Java has no such notions such as record and imposes no structure on the file. Thus, programmers need to structure files to meet application requirements. It means nobody's going to structure that file for you. If you're a programmer, you know how the output is expected to be, so you present it in that specific way. Text files are human readable as opposed to binary files. And we have a lot of text file examples you're going to see here. Creating a sequential access file, what you use is a formatter. A formatter is used to output formatted data to text-based streams. And we have some examples to show you. There are 3 operations to consider: opening the file, writing to the file, and closing the file. Opening the file, writing to the file, and closing the file. We also have some exceptions associated with writing to a file: the security exceptions, file not found exceptions, formatter closer exceptions, and also your system.exit that allow you to exit on certain exceptions depending on, again, how you want your program to be. The whole idea of the sequential access text file is that you need to represent your data in the particular order you want it to be seen, As such, your code must be neatly written in that frame, with that frame of mind, having the necessary exceptions in place to handle errors that might occur. Example, let's see. All right. So we have our sequential access file that stores records in order to record the key field. This means that you can read or write file in the order the data should be stored. Again, how do you want data to be presented? You read it and write it in that form. It's suitable for creating log files or even creating simple reports as well. The formatter is used to create this sequential access text file. And again, we talked about the various options you have, or operations you have: open, write, and close. We have examples, 4 examples from 3.21 to 3.24 to show you. So let's jump right there. And if I'm being too fast, because I know that we don't have much time, so I need to just step it up a bit. All right, let's look here. Let's see. Okay, yeah. Okay, so this is where we use our formatter for the very first time. Again, remember, anything pointed out to you is probably a class. So when you see the new word, what are we trying to do? We're creating an instance of that class. It means we're creating an object of that class. So the out you see here is basically creating an instance of the formatter. So when you say out dot later on, we're associating it with all the methods or instance variables that are within this class that we don't see. Text file there is employees.txt. When we have that text file, we want to be able to write the following information. So we now have out.format that specifies how the information is going to be written. Of course, by now you know what this is, all right? And if you don't, these are your format specifiers for your string, but they have some other parameters here that allow us to specify where exactly in that console will the strings be positioned. So the string position is specified by 8, here 15, here 8, and so on. And if in case you see a percentage %n there and wondering what that is your independent version of a new line. So regardless of whatever operating system you're using, whatever program you're using, percentage %n is the same thing as /n, right? So it's doing the same thing, yes.
So it's, I'm a bit confused about the format.
Okay.
The things, because what are you putting into those? Because from my understanding, those formats are to hold space for a certain string.
That's it there.
Yes.
That's it there. ID, name, salary. All right. So the next one, we have SSF, string, float.
So it doesn't need to be a variable of some sort.
Doesn't need to be a variable. No, this is just a direct example, all right? When you're writing your programs, you obviously put the necessary variables where they're meant to be. Do you understand? So if you're doing a scanf to get the information from the user, all right, you feed them where they need to be. I'm just doing a quick example to explain what the formatter is. I'm not bothered about how you get that. I know you know that already. Okay. So in this case, the formatter allows you to specify or to present an information in a specific format or order. What the formatter is doing here is just allowing us to present some data for employees where we now have the ID, the name, and the salary. So this is probably the column heads, if I'll use that word. While the next one here are the information that fills that column head. So their IDs, their names, and the amount of their salaries there. Right. And last, we now close. So I've shown you the 3 operations we mentioned. We open by creating a new object for the formatter. We write that by using out or whatever object name we created .format and specify the format you want to specify. And we close that by saying out.close. That closes the formatter. Right? Okay. Let me quickly do this one so that we can see what the output will be. All right, as you can see from this line here, I'm currently highlighting, we've presented the information to the console, but specifically they're all obeying our rule, which is the number of the position of where the string should start from, right? And we've said the ID, the name, and the salary should start at specific positions like we saw in our code here. Let me go up a bit. Yeah. And we can now see that they are all obeying that rule. So when you see your nice ticket printouts from your POS machines, all right, they all have some format rule they are obeying, which is why no matter how much you print them out, it comes in a specific format. When you see some console-based application or even some graphic application online, they all obey a specific format. And this is just a way of showing you how that format can be arranged. Question?
So with your salaries, I don't see the formatter to space it out, because from my understanding, the number before the S is showing us where the position of whatever information you told it, but then with your float, it's only the how many decimals or
No, it's here. There's an 8 here. None of them. 8.2. So the 8 tells you the spacing, then the points tells you decimal place. Then the 2. You understand? Yeah. So 8 tells you the position, 0.2 tells you the number of decimal places, and the F is just the format specifier. Right. Okay, let's go to the next one. So the next one, here we see we now have a try and catch. In this case, we have our try with resources, and unlike your usual try and catch that can come within your normal block, try and catch allow you to put in some information that will be used within that block, right? And the one of the benefits of having the try with resources is that you don't need to now close that at the end. It closes automatically once that block is executed. So in this case, you now have a formatter log equals to new formatter. And in there, we're now writing, we're having a file writer that writes a audit.log. So we are creating that, and the argument there is true. When we have true, what it means is that we are trying to append to that file called audit.log. If it's a false, it means that we want to truncate or override that. So it means that we are like basically cleaning memory and writing a new file altogether. Right. Okay, so when we do this, what happens is that we're now able to now take in the log of our or the time information, or let me not take in time information. When we do this, we're creating an object. In this line here, we're now creating a new object that will be able to take in the local date and time. And here we're now specifying the format in which it will come in. So we now have now that takes in for time, user login that goes for characters, and also the name of the user that logged in. If the name was a variable like specified, it needs to be here based on who accessed the system at the time. But what this will do is that we'll be able to log in the number of users that tried to access that system. So we're creating a log file here. Remember, we say one of the good things about the formatter is that you're able to create logs and simple reports. And this is one example to do that. So when we do this, we can now see for how many sessions or how many times someone tried to log in to access the system. And maybe I'll show you an example now and it will be much clearer. So the catch here will now be that assuming there was some error within our try, then we now run an IO exception that will now print, go to the print stack trace to print out whatever error associated with that specific issue. My interest now is to show you what the file will look like. Just give me a minute. Let me just open that file quickly. If you look here, we have, we should have this. Let me open it with, okay, yeah. So if you look here, because I've run this so many times, it creates log each time I run that script, right? And you can see the most recent one. If we look, let me see. If we look here now, this is the most recent one based on when the code was just run recently. So we're able to create log files that tracks every time a user tries to access a particular system, and you can monitor those log files and so on and so forth. This is just one example. You can apply to any of your projects and any examples you're looking forward to doing, right?
Was working 3 o'clock last night?
Yes, I was actually.
4 o'clock.
So you appreciate the life of a lecturer, right? Yes, I was up all night actually for you guys. So
Do this.
let's do this. Okay. Okay. The next example here is 3.23. In this case, we have a path created, and the text, the file format we're looking for is a .csv. Notice that we've been able to create a text file, a log file, and now a .csv. So you can create as many file formats depending on what you're trying to achieve within your projects. So path off is what allows us to create that. This is the constructor that allows us to create this. So we now have CSV path. We'll use that in our formatter to create an object called CSV. Again, our file format has specified the format of which we want. What we want here is CSV, means we're going to have columns and rows. So the columns will have headers. This is the header row we're trying to specify. And this is the data row that takes in the information. Again, this is just me trying to do a quick example, so I just impute those values there. If you have some way to collect the values from your users, you can do the same thing as well. Right? If you have product ID, description, and price, we fit it all here so that when we are ready, we can now use a loop to now write it to that file. Right? So in this case, object item, the items allows us to run that loop until item is exhausted, where we go from item 0, 1, 2, signifying each of these. So we'll write this, each time the loop runs. Right? Then it closes again automatically. Why are we not closing this? It's because we are using the try with a resource, and the resource that was entered was this. So one of the benefits of this is that it closes that formatter automatically, unlike the first example where you have to close it at the end. Okay.
So is that the only benefit? So if I enjoy closing it by myself, or if I made a habit of it to close it myself,
you can close it by yourself. That's fine. That's fine. Right. But if you have a specific resource you're trying to use in that program, you can as well use this. So the idea is to show you different ways by which you can solve that specific problem. Again, with this example, if I open that file, you should be able to see the CSV here, product.csv. Let me just open that up fully. And you would see created as such, right? Yeah.
Since it's a CSV file, I don't have to edit to do mistakes on it because it already puts it in a block of its own.
Isn't it comma separated?
So there are different separators you can use with this type of file. I think this one just uses the normal comma separation. If you look, sorry, let me close this, don't save. Okay. All right. So this one is comma separated. The white, this is normal space separated or tab separated, depending on what you want to go for. But this gives you that format I explained. Because in CSV, you're also able to manipulate the file directly. So if you write to the file, you can as well do whatever modification you want to do within that file. That's fine.
I think you can open it as a text file, but then you see where each block is, it's just a comma.
Yeah.
And then those adds a new block.
So the comments are formats are in that instance.
Yeah, but I think it could be writing it straight like this, you can just open it in a Excel sheet. But in a text file, it would be comments where each block is.
There's several separator types.
Yeah.
Be mindful of that, okay? If you go to Excel, there's a place there you can actually choose the separators you want. This is comma separated, space separated, and the rest. All right? Yes. So just be mindful of that. All right. The last example here in the formatter, we have, let's see, 3.4, yeah, it's the one. So with this one here, the goal was to try and implement the exceptions that were identified to us earlier, all right? Remember we pointed out the security exceptions and the file not found exceptions. So I need to do an example that shows you what happens and how that will be seen within your program. So with this one, we have okay, let me take it a step back. in this line, what we did first was to create an object or formatter called alter, and it was given nil, right? Meaning that there was no assignment at this point. But notice that here we now have the assignment where we now say new formatter, this created, right? So that if you're doing this next time, you don't think that you just do this and you'll be good, right? There was already a creation of that object, then I assign it later on. Best practice is that you can just do it at that same line to avoid any issues. Okay. So once we have that, the formatter here is very simple, just printing hello world with a new line at the end. I haven't closed the formatter here because I want to try out some of the exceptions, and I'm going to manipulate it now to see how some of them will pop up. Right? The first one here is that because we've written this, if we run it, let me open the output again, you should see some error that says, let me see. Okay. Hold on, let me close this, make some adjustments, then I'll run it. Right. I taught you that if you open a file, which is what we did above for alter, you write to the file, which is what we're doing here, and you have to close the file. This one does not have a try or catch, so the three principles must apply: open, write, close. When we close the file, it should be fine. But the issue is that if we look beneath, we now try to write to the file that has already been closed. So we expect some error at this point, and that's what I'm trying to do here. So if you run this, okay, let's see. Let's look at the error so that we'll know what to identify. First, if I go into the code, if I go into the results, the first error, the first catch here is our security exceptions. The object is SE for that, and what we're doing here is to do the se.get that gets the message associated with each security exceptions. And what that is that if you don't have the privilege of the directory you're trying to access, it will tell you that you're unable to access this file. It applies mostly with our systems here in the lab. Because I have full authority on my PC, you won't see that error pop up. But if you try to redo the examples on these PCs here and you try to write to some directory that you don't have access to, that error will pop up for you, right? Otherwise, you would have, okay, in doing that, notice in this line, after printing out the error message, we exit system.exit 2. I'm giving different codes so that when we see the output, we'll know exactly which of them was responsible for the exit plan. This one here is our file not found exceptions. We have our object created FNFE, and the same thing applies where we say .get message. Remember, I said in most of these classes we're able to set and to get. All right. So in this case, we're getting the error message responsible for these specific exceptions. If it exits and we see a 3 at the end, it means that this is what's responsible for that specific exit. And the last one here is your formatter close exceptions. This one here does not hinder your progress because there's no exit plan here. What it does instead is just to give you some kind of information or warning that tells you that try to write after the formatter was closed. So remember, we already closed it above there. So we should see this file or this error popping up because we tried to do that. The final block here tries to just close it. So you can close this as many times as possible. The close has no limit. You can close it 5 times, no errors pop up. All right. So just in case it wasn't closed above, finally close it here. That's what we're saying. Okay. Now that you know what's happening there, I think that's the end of that. We can as well just start the program. Let me see. Okay. Then here, this last print statement says finish without fatal errors. In this case, it will print regardless if none of those things work, because this is not within the try and catch block. This is on its own. So we'll always see some printout that tells us that. And I've closed this part. I think I should open it so that I'll ignore everything that follows underneath. And we just stay in that example for now. Let's run it again. Okay, so if you look at the example now, you see the output The error we are having says what? The formatter closed, exception, try to write after the formatter was closed, because we closed it already above, and we try to write afterwards, so we get that error. However, we still continued regardless of that, and so what's finished without fatal errors, meaning that even though we've written 3 catches, the last catch does not exit the program. It just gives you a warning and still continues with the operation. And this here is telling you that has actually happened. So we finished. Let's try and implement another of the exceptions so that we see how it works. Let's see. Okay, let's close this. Okay. So this one here, the part not found one is when the part is not found. So I'm going to try and create. I currently have a part here that is found. So if I open my directory, you will see the forbidden text in here. This one is there. And in there, you see hello world. I can open it up clearly so that it's clear for everyone to see. Open. And we see the hello world text that was printed there. But I'm going to give it a different path now so that it should show me that the path has not been found, and we'll get that error popping up now. Okay. So with that, let me say I try to do C dots. Black. Okay. I know this does not exist. All right. So I'm hoping that we'll have some errors that pop up after I run this. And there you go. So in this case, we see file not found exception, and it's pointing to the path I've specified, that it does not exist here. The system cannot find the path file. The errors you're seeing here are the errors associated with the get message you're seeing, but look at the return type here. It's what? 3, signifying that that's the 3rd system exit plan we did for that catch. All right. So with this, you can track where your errors are. If you have your try and catch within your programs, you can see what kind of errors you are having and what you've anticipated that the errors would be, and also know how to address them accordingly. All right. Like I said, the first one, which is 2, which is security exceptions, will not work for me because I'm not restricted in terms of my privilege on this machine. But if I had done that on this PC, then we'll have that popping up as an error.
What if the tracks right to the system to Windows system that you see that is an error?
Okay, I can try that, but not now because I'm almost out of time. Yeah. Okay. Let's continue. So with this one now, let's see. I'm going to close the exit here so that we're able to continue with the program. Okay. All right. So what we've been looking at all this while is the sequential access text file. We looked at 4 examples that have treated them differently and how to find them or how to use them. My hope is that if you go back and rewatch the lecture, you see the examples we've done. And if you look at the code I'm going to upload later on to make it much easier for you to implement that in solving any problem or even use it in your projects in any way you see fit. All right. We have your own examples here that created for account record class. Please try this at your own time as well to see how the methods operate and what you can get from this. We also have a create text file class. You can try the example as well. And this is the test script for that last example you've seen. Okay. I also did the read option, but I'm going to explain it here. We still have 3 steps with the read option. We have the open, the read, and the close. They're still sequential. When we write, we can also read. But with the reader, we use a scanner. We use a formatter to write, and we use a scanner to read. We also have exceptions like found not found exceptions, no such element exceptions, and illegal state exceptions as well. And of course, I have examples for you for all 3 of them within that code. I don't know if you can go through them all, but I'll show you what I have for you. If you look here, you'll be able to see at this point the scanner is used to read these. I pointed out the constructors, or rather the operations file, open file, read data from file, and close file. And we also have some examples from 3.5 to 0.8 that we can see. We'll just touch them briefly, quick, and run through so that we can land in the last part that is very important, which is object serialization. So with 3.25, we have this. Yeah, okay, so 3.25. Okay, so with this one, we're still looking at the employee.text because we know that information is there already that's been written, so we can as well read from that. So we create a part called text parts. Notice it's different from CSV parts. This is just me trying to read that. But I'm going to feed that into my scanner there, which is the text part as an input to the scanner. And my object created for scanner is called in. If I put that in a while loop, I'm able to read while as the next line until I get to the very end. So if I do this, I should read what was written to employee. Let's just open up what employee.text is saying so that we'll be very sure what's happening there. So remember, it's showing us this information, which is the IDs, the name, and the salary of the employees. So it means that if I should run that code, I should see that information pop up. Should have sorted it out. Let me see. Okay, the part is still, yeah, I didn't change the parts. Just give me a minute. Okay. Okay, so here we see we have that information. Let me see. Yeah, so this is where it's reading to this console. Initially, we wrote it to file, but now we're reading it from the console, and we read it in this form and in this format. So that one is sorted. The next one we're seeing is 3.6 here. Here we're saying we have no file in the text, and we've done this so that we can catch the exception that says file not found. So if you give a message, because you've seen the previous example, we know this is possible. All right, so I'm not going to go into that. 2.7 here, we now have some numbers. Say we have 4 numbers written in a text file, and I think I have that text file open up here. Not this one. This one. And I've just written a bunch of numbers, 100, 200, 300, 400. But the idea is that we're able to read from that text file. What we're interested in reading is integers. When we read the information, if we exceed the limit provided in that specific file, there's an error that pops up at this end. That's what we're looking at here. So the error here is no such element exception here. So we have our number.text, we feed it into in again, we run into our for loop, and if there's an error pop up, and the error pops up and tells us no more numbers left to read in this case. So I think we've had, let me run this so that you see, and you see that here it's read what? Up to 400, and after that it tells us the error, no more numbers left to read. Why is that? The maximum for our for loop there was 5, right? And it was intentional so that this error would actually pop up. If I make it 4, nothing will pop up. It won't catch anything. So that is why we're trying to show you how that specific exceptions actually work. Next one is our 3.2.8. Here we have Alice, Bob, and Charlie as a text sent into our scanner, and we want to read the next. What we read is Alice, after which we now close the information. So if we try to now see if we can read the next thing again, it gives us an error, and the error is an illegal state exception that tells us try to read after scanner is closed. All right, so the error pops up as well if you look at that. So that is the end of your sequential access, whether for reading or for writing. I've come up with several examples, simple examples that you can use to understand so that when you try to implement what's on the slide again, it's much easier for you to now follow. The next thing we're looking at now is our serialization. Let me go there quickly. So 3.3 is our object serialization. So serializing an object means turning that into some single stream of bytes, all right? Which includes the objects, data, and information. So whatever information is shared with that specific thing, it does it. What deserialization basically means, we're going to rebuild that back into memory. So say you take some things off your shelf, or you go to your closet, you want to go out, go to your closet, take off your shirts, take off your shoes, put your dress on, and you go. So while it's on you, you've serialized. It's now fitted in one byte, all right, or stream of information. But you decide not to go out anymore, take it off, put it back in the closet, all right? You've deserialized. Simple example. So it's easy to see, all right? One refers to writing, the other one refers to what? Reading. And there's some example we have associated with that. So for object serialization, we use things like interface serialization, and you say when an interface is serializable, it means that we are tagging that interface, that interface does not contain any method. Maybe I'll use the word active method. It contains some structure, but not the method. The example I have here, we have some interface and drivable. It's more like a contract that tells you this is how we're going to operate, or a blueprint, but we're not necessarily doing anything with that. And here we have void start and void stop. If we want to go ahead and implement the interface, then we use the keyword implement. That helps us do that. So implement is used when we want to declare a class as serializable. So we want to be able to convert what the class will provide into bytes. So this will be able to now supply the real code into those methods that were defined within our interface. So before here we have void start, void stop, but now here we can now define exactly what happens in void start and void stop. So in our interface here, we can now say class car implements deliverable and drivable, and here we now say print engine on or print engine off, right? So interface did what? Was able to create like a contract, a blueprint, something that tells us that this is what you're going to require if you want to implement this, while trying to now implement the code in our class. We now get to define what happens within that specific method. All right, so this is just a simple way to describe that. If any variable in the class is implemented, or is a class that implements, if a class implements serializable and the variables do not want to be serialized, then we use our transient keyword to be able to ignore the serialization of that specific variable as well. And I think there's an example for that there. Right. If you remember access modifiers, we're able to change, or non-access modifiers, we're able to change the states of certain behavior of our variables or our methods, and that's what we're trying to point to at this point here. Okay, so 3.31 is an example, and let's look at that quickly. Do not worry, you have access to this, and if you have any questions, please ask. If it's too much information, you'll get it, don't worry. All right, so here we are creating an object in memory. Say we have Alice, 30, and secrets. No, hold on. I missed something. Okay, no. Okay. It's the one, the example. Okay. So here we're creating an object in memory. So person original equals to new person, and the person here requires some information. We should have some objects or some class called persons down here. Yes, we have a class that's been created called persons. So just so in case you're asking where did the parameters come from, how do you know what persons are? We have the class here, and this class is implementing serializable. So we have a private static final long serial versions for version control. We have a private string name, private int age, and private transient string for session token. So this here is not going to be serialized because we specify that all this is for session that is transient, so it's not going to be taken in when we're trying to convert that into readable bytes. But the reason why I'm bringing here is so that we can see where the various inputs are coming from, and the method associated with that specific class. It's just a class, not a public class. Remember, we can only have one public class within our script. Right? Okay, so if we go back here, we see Alice. We see line 250 there, and we have the argument Alice 30 and the secret 123 entered. We print what the original file will be. Then we serialize that by creating a new object output stream. Within that object output stream, we now have a new file output stream and pointing to file. And here we now convert what that will be by saying out.write object of the original. So the original was saved as the object in memory of a person, and here out with a double T was created in our try here as the object for the object output stream. So what we're doing here is now writing that information of original in our object here. So the catch would be if there's any issues whatsoever, we should be able to catch that successfully. And if we run this, we'll see that. Let's see, maybe I should do this one first, then we'll look at the other one down later. Let me run this first. Let's see. All right, so if we look here, the original data has been presented here as Alice, age, and token that was entered for the information when we're trying to serialize it. We're able to save it into a file called person.dat. So you see those .dat files you see PCs on your programs. That is it. Let me open it here so we can see it as well. All right, so notice that the file is the highlighted part here. I don't think this can open with, let me see. Right, so it's trying to give you some information as to where it's coming from. But as a programmer, you understand that obviously you can't open this particular file in this format, but you can pick up some sense since you wrote the program that okay, this is person. We have one of the inputs, Alice, and so on and so forth. And obviously, it's a Java language that was written as a string. Okay, that's just the file type. The next thing is how do we restore the file? It's written as a .dat, but we're now trying to now take that .dat and read it and get the desired output, and that's where deserialization comes in. All right. You can already see the output that when it's been restored, we can see we get the information, but notice that token is what? No. And that's because we called it transient earlier on, meaning that we're not going to serialize this, so there's no need bothering about this particular information. All we needed was the first two, so when we restore the information, we only get the first two, which is Alice and age for name and age. Alice and 30 there, right? And that's what I'm trying to point out to us here. All right, so let's look at that deserialization code and see. So here, excuse me, we have a person clone equals to null. We now create our object as usual, giving it a different name, just input here. So now clone is equals to person input.read object. With this, we're able to now convert the byte back to our graph-based type. All right. And if there are any issues whatsoever within that conversion, our exceptions will be thrown again to tell us that there's an error at this point or not. But the reason why we're able to read that successfully is because this try worked without any issues. So we saw that we're able to get the files or the variables we entered initially to the output without any problems. All right. Okay. So the last bit here is just what shows us what's happened. So when we printed original above, we're just printing restored beneath so that we can see the difference between those files. And that's it, yes.
So does transient mean it's temporary or?
Transient. No, it means that we'll not serialize it. So when we serialize, it's like taking things off the shelf, like I explained before. We're trying to convert those things into byte forms, right? It's like taking a graph-based object and converting it into a byte-based object so that we can process that. The format we got was what? .dat, right? But now we try to open .dat with your text, with your notepad. What did it give you? Scribbles. Not much information. You can't do much with that. But when we use this deserialize function, we're able to get back the information perfectly, except for where we did not serialize, which is the last one, the token. And it was done intentionally to show you that if you do not want, okay, when you collect sensitive information, right, from when you're doing your designs, sometimes you want to store the information in the format that even certain persons cannot necessarily read, right? Say you store it in the BAT file, all right, and what you're collecting was your credit card numbers of your users accessing your site, your house addresses, phone numbers, sensitive information, all right? When you put transient in those parameters, it means that there are some that you do not want to get back. So I can put a transient on the phone number. I don't want it back. I can put a transient on the house address, but I want to get the credit card number because I want to build that user from time to time on my site, right? So that one is a good example because it shows you that certain information can be retrieved in the format in which it was given, while others can be ignored within that same process. Any questions? All right, we're almost there. Let's keep going. The last one here, let me go back to this slide quickly so I don't lose. All right, so we finished the sequential access. We went to the object serialization quickly. We talked about serializing an object and deserializing an object. You have access to the slide. If you read up this information, you will see that it relates to what we're currently doing. They also have their own examples as well. Please, again, try to see if you can implement this. Otherwise, you can still work with what I have, and whatever we do in our practical is still fine. But I always encourage you to do this so that you get a more holistic scope of what the problem is. The last part here is, let's see, is opening files with your J file chooser. So this here is more GUI in terms of its operation. What it allows us to do is it allows the user to create a dialog box where he can now choose the file paths he wants to explore or where the file is. So far, what we've been doing so far is that we've been using our formatter to get the file path, either as an absolute path or a relative path, and write to those paths in specific formats, right? But what this will allow you to do is to actually now choose the paths physically, like GUI, the path location, and choose the file you want to read or extract, right? In terms of what it can do, it sets file selection mode. It sets that allows for files only, directories only, and files and directories. Then it has a show open dialog that displays the J file chooser dialog to open. So click on that will open. Whatever is mentioned here can be captured in the example I have to show. So let's just go quickly to that so that we can move on. They also have their own examples. So you can see here that what we're looking at now is your swing. All right, so we'll now try to see how we can use the GUI and the swing import tool to be able to perform the necessary JFile chooser code or syntax that is highlighted here in yellow. Right? Okay, let's look at here. All right, so in this example, very quick example, what we've written here is for you to be able to create an object with the JFile chooser. So the object we call the name chooser here in line 281. So when we have that, we're now able to now open up or show the dialog box by using the chooser.show. When we put the dot operator there, it means that we can relate it to some method that has been created in the class, in that class. And in this case, it's the show open dialog. The input there is null, and null because we want to put it in the center of the screen. They might have other inputs you may want to explore, but I see that that's best for most, or that's default for most of the dialog box you see. They pop up at the middle of your screen for you to use. Next, we have our if statement there in line 284. So if result, whatever the result is chosen from there is equals to the J file chooser.approve option, then you're able to perform the next line. And what does the next line do? It's file selected equals to j equals to chooser dot get selected file. So that line allows you to now retrieve the selected file you've chosen to be able to pick whatsoever file you intend to pick. Otherwise, it tells you no file chosen if you ignore the OK button or the choose button and just close the tab. That's what you've been seeing all the while when I press this. See it pop up on the screen this way. And that's the GUI option here. So if I want to access one of the projects we've been working on, one of the files we've created, I can go to NetBean project. I can look at, where is it? I think it's working with student registered. Yeah, and you can see you have the employee.txt, forbidden.txt, numbers.txt, person.dat, product.csv, it's all here, right? So if I click on, say, product.csv, the file name is chosen there. When I say open, what we see is that it tells me you pick and points the path to which the file was seen. So it tells me the path and also at the end, the file that was selected at that point there. So this is a simple example, but the idea is to show you that you are able to use the J file chooser in any of your programs or in any of your projects to choose specific files if you're dealing with directories and so on and so forth. In another case, if for instance you choose not to select, say you click on cancel, all right, it gives you the response, which is what the last option was, that no file was chosen, and that is what we see as the output in our else scenario here. All right. Even though you decide to just close it without that, just close it normally, it still tells you no file was chosen. Whatever you use. Yeah.
So, but to actually open the file, we need something else.
Sorry.
To actually open the file onto your system itself, you need something else.
You need something else.
Yeah, because you showed us one where you picked certain files, but then you showed the file part that you picked.
No, that was the goal. I wasn't trying to open the file. I was just trying to show that you can get to that part. All right. Any other questions? Any other questions? No? Okay. So just to recap, what have we talked about today? The first thing we talked about was on data, temporary data, persistent data, file classes. With your file class, we talked about the different constructor it has. We've shown we've shown some syntax of how the four of them will operate, but gave two examples to 1 and 3. We're able to relate, or at least explain what a relative path and an absolute path is. I'm also showing an example of the separator character that allows you to create a separator independent of whatever platform you're using, whether it's Unix or Windows. Right? We explained the sequential access files we have, and that we can use the formatter to write to those files, and the scanner to read from those files. And we have several examples that show that specifically, that shows the exceptions that will pop up in some scenarios. And they were done intentionally so that they can give you a bit of knowledge that you can apply when doing whatever project you're going to be doing. The next thing we looked at was on the JS chooser was our object serialization. Object serialization tells us that we are able to now take a graph object or any object and turn it into byte streams that can be used. And when we deserialize that, we're able to convert that back into the original format. An example was done where we took in some data that we have, converted that into to serialize some of that, and now deserialized it. We also specify that if there are specific variables within your program that you do not want to be serialized, maybe because of sensitivity, you can create it as a transient, and that will allow it not to be serialized when it's recovered or converted back to memory, right? And the last bit there was to talk about the J file chooser, which is our GUI. We use our swing. Notice that there are a lot of import tools I have here. I haven't gotten around to explain all of them, but as you practice with this, you see what they do. The swing there specifically allows us for our J file chooser, allowing us to be able to perform the operation to choose or to navigate in our directory. The java.io is our input output files. It gives us aspects to a directory where we can choose input output methods and classes. So each of them, like your file writer, IO exceptions, file not found exceptions, all exist within the .io directory itself. Then we also have the NIO that was used here, which is the new input output directory that was created with some files. Notice that we still have file.files, different from the original file that we saw there, but the newer ones that have been created, and we use them within our program. For the time, in case you want to create log files within your program, we use the time.localDateTime to get that. And the util formatter was used to write. The same thing as the util scanner that's always used to what? Read. Obviously, the formatter close exception falls within that category. And also the no such element exceptions fall within that category. So we've been able to demonstrate as much as possible what we have on the slide with some simple examples within the time limits we have. My goal for you guys would be that you use the time you have on the weekend to digest as much as possible this script that I have prepared for you, and also the notes and the slide you have for this week, so that when we meet next week, we'll be able to go a bit further. And the next time we do the next prac, we'll try some of these things out, and hopefully we'll have no issues. All right? Any other questions? No? Sign the attendance. All right, so the attendance should be active now. You can quickly click on that if you haven't.